First close the project if there is any previous project is there. Project, new microvision project. Okay, I will create one project, that is part B. Already the same name is there, so and give the name part B A, part B1. This is a project name, so no need of giving any extension. After this, it will ask for selecting the device. So we should select this legacy device database. Under this, depending on which kit we are using, we have to select that processor. Now we want under NXP, that is LPC2148. So instead of checking like this, I can directly search here, that is LPC2148. Click on OK. Now this program I am writing for uh, interfacing hardware. So when we are interfacing hardware, we need this startup file. So we'll press on S. It will tell it already exists. You want to overwrite yes. Okay. After this, under this project, we don't have any file. Okay, we can see here there is no any file under this project. Only the startup .s file is which we are added just now, that is there, but that is not our program. Now depending on the we want to write the program. For that, click on file, new, which is start typing the program here. Okay, now I want to write the program for interfacing DC motor, interface and control DC motor. Already I have written the program. First I will save this program. For that, we should click on save button. So when we are clicking on save button, it will ask for giving the file name. I can give any name for this. So this is for DC motor, so I'll write it as a DC. Okay, DC PRG, and we should end with the .c extension, because what I have written here is a C program. So .c. Okay, and I'll save this in the folder example PRG. So when I'm saving, it will change its color depending on what is the instruction and which one is the comment. Now we don't want these first two lines are not a instruction, so I'll make it as a comment by backslash. If you type double backslash, then this will become comment. Okay, now in this program we want we want our program we want to use the LPC2148, so I'll use the header file for that. The header file is, I'll zoom it, you can see it properly. Okay, now I'll use the header file, that is LPC214x, means it is the same header file for all the 214 series. The next is we should start all the program what we are writing, what is there in the main program, that it is going to main function it is going to execute. So the return type of this main program should be int, and input for this main program should be y type. Okay, now first I want to decide which pin I am going to use as a input and which pin I am using as a output. For that I should define in a IO direction. IO 1 dir means this is port 1. Okay, so port 1, what is the direction, and input output port 0, what is the direction. Okay, first we'll see in our kit which pin is used for a DC motor. Okay, this is the kit what we are using. In this you can see our LPC2148 is here, and there is a 8 switches, 1 2 3 4 5 6 7 8, and one more is a interrupt switch. Okay, and we have here DC motor interfacing pin and stepper motor interfacing pin, and we can see this 4 7 segment LED here. Okay, and the LCD display like that, buzzer and ADC port, all these are there. Okay, and key matrix. Okay, so first we should understand which pin is connected to, I mean which pin of the ARM processor is connected to these switches or these devices. Okay, now our program is DC motor interfacing, and we want to control this DC motor. So we want to know which pin of this DC motor is connected to R, sorry, from arm which pin is connected to DC motor, and from arm which pin is connected to these switches, because I am using this switch for controlling the direction of the DC motor. Okay, so off, one switch for off, one switch for on, sorry, one switch for clockwise direction, one switch for anti-clockwise direction, and one switch for off direction. So I need the 3 pin from this switch and 2 pin from the DC motor. Okay, so we'll see or which is that pins. Yeah, so DC motor pin configuration here, for I mean we are connecting pin number 29 and pin number 30, that is port 0 fifth pin and port 0 sixth pin. So if port 0's fifth pin is 1 and port 0 sixth pin is 0, then DC motor will rotate in clockwise direction, and port 0 fifth pin is 0 and port 0 sixth pin is 1, then DC motor will rotate in anti-clockwise direction. And there is one more pin, it is to enable the DC motor. Okay, but we are not using that pin. So okay, next is I told we need the 3 switches. So 3 switches, like out of the here there is 8 switches. So 8 switches connected to pin number is given here, that is 16 12 8 4 and all. So we want the port number, that is P1 16th bit, port 1 17th pin, port 1 18th bit, port 1 19th pin, like that, port 1 23 pin. So we want any with the 3 bits of this key and 2 pins of the DC motor. Okay, so we'll see the program now. Okay, in my program I am connecting 16, I am using 16 17 and 18. So 16 17 and 18 is the switches for I'll show that. Yes. Okay, 16 17 18 is the port 1, 16th that is switch 1, port 1 17, that is switch 2, and port 1 18, that is switch 3. Okay, so you can see here switch 1, switch 2 and switch 3. The port 1 16 bit, port 1 17th and port 1 18th. So this is a switch. So I have to give the input to my um ARM processor. So I have to define the direction. The direction is it is the input. So if I give 0 to that particular pin of the port 1, so port 1 here IO1 means this is a port 1 16th bit. If it is 0, that means the port 1's 16th bit is used as a input pin. Now for that pin switch is connected. So if the switch input is 0, then it is taking that 0 as a input signal. If switch input is 1, then it is taking a 0 as a if the switch is uh, high, then switch is pressed, then if it is taking a 1 for that input pin. Second line here, it is a we are telling the direction here. It is we are storing 1 into that particular pin. That is I'll go back to pins. Yeah, here port 0 fifth pin and port 0 sixth pin. Port 0 fifth pin and port 0 sixth pin uh, is used for DC motor. Okay, so if that is used for DC motor, I should send data from the processor to the I should send the data from the processor to wait, I'll show the diagram. Okay, so input means first these switches is used as input for this ARM processor. Okay, output means from the ARM processor we are sending the data to the DC motor. So DC motor pin. So first I should tell these three pins are the input pin and these two pins are the output pin. So first we are defining the direction. The directions are for DC motor it is a output. For step switches it is a input. Okay, that is what we are first defining here. If whatever the previous value, it is going to store 0 into that particular pin, and we are defining the switches as input, and by storing 1 we are defining it is output pins. Okay, next we'll start with our program. We want to check what is the switch input. If the switch input is uh, if the switch input is 0, okay, if the switch input is 0, then it is clockwise key pressed. Okay, out of these two switches, sure, okay, out of these three switches, 1 2 and 3. So first one, switch 1 is for clock 1 direction, and switch 2 for counterclockwise direction, and switch 3 for off the uh, here the program it is using a simple technique that inside the while loop. So it means it is keep on checking for the pins. Okay, so switches it is going to check. The switch is 16, 17 and 18. 16 for clockwise direction, 18 for off stop the rotation, and 17 for the counterclockwise rotation. So if the switch 16, the first switch is pressed, it is going to send uh, 40. 40 means if you write in binary, it is 1000000. So there is 6 zeros before, means fifth bit is 1 and sixth bit is 0. If fifth bit is 1 and sixth bit is 0, then it is doing the clockwise direction. That is what we are showing here. If I mean, by sending 40 to port 0, 40 to port 0, the port 0, it is used for it is connected to DC motor. So by sending 40, we are making 40 fifth bit. 40 fifth bit is 1 and sixth bit is 0. Okay, that's why it is going to rotate in the clockwise direction. The next I want to make port 0 fifth bit is 0 and sixth bit is 1. That is by sending 20, showing you. Okay, by sending 20 to the port 0. So if I send 20 to port 0, it is rotating in the anti-clockwise direction. And if I send 60 or if I send 00, then it is going to rotate. I mean, it is going to stop the rotation. Okay. So only this much is the program. Like only it is inside the while loop. So it is keep on checking the switches, and depending on which switch is pressed, it is going to send that particular value. Now, after writing the program, we should build this program. So when we are building this program, it is going to check for the syntax error. Okay. Okay. I have made one mistake here. I have not added this C program into my project. So I'll add existing, that is dc prg.c. I'll add this, then build it. Okay, it is showing 0 error and 0 warning, but it is not created the hex file. So what we should do, go to option for target 1. This is available here. Option for target 1. I hope you can see it. Yes. Okay. Under project, option for target 1. Here under output tab, click on create hex file. If you click on create hex file and press OK, then again if you debug this, it is going to create the hex file. You can see here it is creating hex file, means it is created the hex file, and hex file name is same as project name. Next is we want to load this hex file into the kit. Okay, so to upload the program, we should open this Flash Magic. The Keel software and Flash Magic, everything is available online, and it is free of cost. No registration is required. Now, first step is under this is select the device. Device what we are using is LPC2148. So we should search for that LPC2148. Okay, it is coming under ARM7, under ARM7 pack. So LPC2148, this is our device. Next, we have to connect the kit. Oh, a minute. So we have to connect this kit, which is available in the college. Okay, we have to connect this kit. For connection, you have to connect, there is a USB cable. The USB cable should be connected to this port of the kit and to the computer. When you connect to the computer, it will show one port. So first we have to identify which port is that. So depending on that, we have to select the port. Most of the time it will be port 3. So port 3, and what is the baud rate? Baud rate is generally we are using 9600, and for our interfacing kit also it is 9600. And next, interface non-ISP and all these different methods are there, but we are using this non-ISP only. Okay. Next, oscillator frequency. Oscillator frequency is 12 megahertz. Okay. In our kit it is 12 megahertz. We have seen in the first lab only it is 12 megahertz. So we have to type here 12 megahertz and erase all the block code used by hex file. Erase blocks used by hex file. Means if previous there is a program, it will delete that program and it is going to upload the new program. Now the program what we want to upload, we should browse that. So that is there in my desktop, in the folder example program, under that objects. So the program what I built now, it is created the hex file. So hex file is part B1. Okay, so select that, open. So that hex file is created now. Okay, and click on verify after programming and then click on the start button. If the device is connected, then it will start uploading the program. But in my case here now device is not connected, so it will not show anything. Okay, so after you are uploading the program, the same thing I will show with the simulation. The same kit type circuit I have rigged up in the Proteus. This is LPC2148, and the minimum requirement for that is capacitor is connected, and reset button, and the power supply. Power supply is 3.3 volt. Now for our experiment, now DC motor interfacing, I want a DC motor. That DC motor is here, and 3 switches. Okay, so these 3 switches, which I'll show, zoom it. Okay, yeah. So these 3 switches is connected to port 1. 1 minute. Okay, is connected to port 0 16th, port 0 17th, and port 0 18th pin. Port 0, port 1. Yeah, these 3 switches is connected to port 1 16, port 1 17, and port 1 18. We can check the program again, and the DC motor is connected to port 0 5 and port 0 5 and port 0 6. Okay, so we can check that DC motor is connected to port 0 5 and port 0 6. If you want, I'll move this DC motor here. Okay, so DC motor is connected to port 0 5 and port 0 6. Now by using a flash magic, we can upload the program into kit, right? So after program is uploaded into the kit, it is like we are loading the hex file into the IC. The flash magic is used to load the hex file into IC. So what I will do is the what hex file I have created just now, that I'll copy into my uh, IC. Okay. Now after this, if I run this program, if I try to execute the program which is there in the LPC2148, now you can see, zoom it, yeah, you can see here the DC motor is not rotating, right? Okay, DC motor is not rotating. Now I'll click on switch, the first switch which is connected to port 0 16 pin. Right. Now if I press the first switch, it is in the clockwise direction. If I press this last switch, it is in the off mode, means it is not rotating. Okay, and the second switch, DC motor is rotating in the anti-clockwise direction. So this is what our program, it will keep on checking the switch. If the switch, the first switch, P1.16, to that pin which switch is connected, if that switch is pressed, then DC motor will rotate in the clockwise direction. You can see this here, it is rotating in the clockwise direction. If you click on second switch, it is rotating in the anti-clockwise direction, and the third switch, it is going to stop. Now we'll try to load this hex file into our kit. So for that we have to open the flash magic, and we have to set this device, and device is LPC2148, and the baud rate is 9600, and oscillator frequency is 12, and erase block used by hex file, and browse the file. I'll show that. Okay, now we are browsing the file, the hex file what we have created. After that we have to click on start button. We can see there it is loading on the device. When it is finished, we can see in the kit the uh, yeah, okay, so switch 1 to rotate clockwise, switch 2 rotate anti-clockwise, we cannot make out it because it is very fast, and switch 3 to stop the DC motor. So switch 1 to rotate clockwise, anti-clockwise, and stop. So it is working properly.